Good morning, everyone. Today we have our last rule for exponents, and that is how on earth do we divide exponents? Well, you can already see that we're going to be using subtraction, but even without this rule written out for you, dividing exponents, technically you already have enough information to solve any sort of problem like this using the concepts that we already know. For one, you already have rules for multiplication with exponents. And those rules told us that if I had something like x to the 4th times x to the 7th, I could add those exponents because they have the same base with multiplication between them, and that would give me x to the 4 plus 7, or x to the 11th. And I also knew that if I had something like this, x to the 5th over x to the 3rd, I could rewrite this one in the bottom of the fraction as if it had a negative, because in order to move it, all I have to do is switch it to a negative exponent. So this would have actually been written as x to the 5th times x to the negative 3rd. And if I wanted to figure out what that is, well, I just do 5 plus negative 3, or 2, and I'd be left with x squared. So you can see how already I could use what we know about that negative exponent to solve any sort of fraction. But you might notice that this provides a shortcut. If you take any fraction where you have two powers with the same base and only multiplication, so there can't be any addition signs, okay? As soon as you see addition signs, it's all over. If you have that, you can subtract those exponents. Now let's look at this one quickly written out so you can see why this works also logically with multiplication. If I had x to the 5th over x to the 3rd, remember that all this is saying is you've multiplied x by itself 5 times. So I've got 1, 2, 3, 4, and 5. And on the bottom, x to the 3rd is just x multiplied by itself 3 times. Now, don't forget that if everything is multiplication, you can cross out values that are the same. So this x and this x could get canceled out. This and this gets canceled out. This and this gets canceled out. This division is canceling out the multiplication. That leaves you with 2 x's in the top, or x to the 2nd. So that is how we're going to use this rule. And I want you guys to remember with dividing exponents that you do have to keep in mind that we don't like negatives in the exponent. So if you end up with a negative in your exponent, try to fix that, change it into a fraction. So let's just start with x to the 6th over x to the 4th. That's going to give us x to the 6 minus 4, and I know I can do this because I have no addition or subtraction, and I have exponents with 6 and 4 in the powers there. And x to the 6 minus 4 is x to the 2nd. Again, you can pick numbers to type into your calculator here. Let's just use 2. 2 is a great substitute. If x is 2, that means that if I put 2 into here and into here, I should get the same answer. So I should get an answer of 2 squared, which we know is 4, right? If I put 2 in for x over here, I should also get 4. So 2 to the 6th divided by 2 to the 4th, well, that is 4. So that shows me that if x equals 2, I get 4. And if x equals 2 here, I get 4. So that's just me checking my work. Now I can do that here with 6 to the 5th over 6 to the 4th. That's going to give me 6 to the 5 minus 4, same base, no addition or subtraction. And 6 to the 5 minus 4 is 6 to the 1, or just 6, because anything to the first power is just itself. And again, you could type that into your calculator to see that that works. Now we're going to get something just a little bit different. If I have x, or 8 to the 4th over 8 to the 6th, well, here I know that I have the same base, so I can just use subtraction, because again we have division here, we're not going to be adding, to do 4 minus 6. Notice it's important that the number that comes first is the number in the top, okay? You can't switch the order of this, otherwise things will go wrong. Now this is going to give us 4 minus 6, which is negative 2. And here, remember that we don't like having negatives, but what we can do instead is flip it to the bottom of a fraction, and that will give us the positive exponent, 8 to the second, in the denominator here. So my final answer is 1 over 8 squared, or you could write that as 1 over 16. And you can type both those into your calculator, this, and it would work out. By the way, look at how this answer actually makes sense when it comes to canceling. If I was to write out my original as 8 times 8 times 8 times 8 in the top, 8 to the fourth, over 8 to the sixth, 1, 2, 3, 4, 5, 6, I can cancel out 8's until I'm left with just the 2, or 8 squared, in the bottom and a coefficient of 1 up top. So that'd be 1 over 8 squared, or 1 over 16. So you can see how this method also works. If you're having trouble remembering the rules, don't forget, you can always use just logic to work things out in math. Okay, so for this one, we have negative 3 to the third over negative 3 squared. Notice that this negative is inside the parentheses, not with the exponent, so no things are moving, right? Because you only move them if the negative is with the exponent, not if it's with the number itself. Well, the bases are the same. We have no addition or subtraction, so I can just do negative 3 to the 3 minus 2, top minus bottom, and that's going to give me negative 3 to the first, or just negative 3. Last but not least, you might notice that this is one thing divided by itself, so that has to be 1. But you can also think about this in terms of exponents. We have x to the 4 minus 4, which is the same as x to the, 4 minus 4 is 0, and we know that anything to the 0 power is 1, so you can see again there's multiple ways to get to the same answer here. And don't be afraid to try out a few different methods. So we're going to start by practicing this idea today, and tomorrow we're going to try out the second part where there are a bunch of rules going on all at once and see how to set those up and work through those sorts of problems. I hope you guys have a great day. Don't be afraid to drop in with questions.